First of all, welcome everyone. I don't know which parts of the world we have. So greetings everyone. Today we are going to the topic is supply chain attacks. How open source and OSINT can fight together. Open source has been seen. We have seen the worst phase of the open source due to the geopolitical situations. So today we're going to dive into one of the most critical cybersecurity challenges of securing open source supply chain. So first of all, I'm Surya, and this presentation will explore how OSINT as bombs can combat threats like Log4j, XJ Utils, and protestware. So let's get started. So before we start, a little bit disclaimer: the views and tools discussed today are not my own, and it gathered public information, and it in any way doesn't represent of my employer. All data is sourced from public reports and research. Everybody is free to use it, and don't quote me or my company name anyway. So let's start with the importance of supply chain security. VB open source is there for a while, and we all use a lot of open source tools on day-to-day basis. So, but do we really care about supply chain security? So, the attention started. The attention started with solar winds. It's one of the huge attack that happened, and Log4j and XJ utils are some of the recent examples that led to giving the importance of the supply chain. So open source dependencies are like backbone for modern software, but they also are like attack vectors. So let's examine some of the risk. I did formulate some case studies. So understanding the open source supply chain security, open source um, is not risky in any way, but like with the open source evolved a lot. Like since Unix, like we have seen a lot of open source software, and it's one of the source code is available. It's transparent in nature. Like if anybody wants to look at the source code, they can look at it, and if there are bugs, like those are openly discussed in the open source community, and but the same transparency is also kind of becoming double-edged sword. So left pad is one of the example on open source library. Removing of that library has broke thousands of applications, and Log4j is like another trans dependency went unnoticed. We need better ways to track and secure these components, right? So previously we used to download software just like that from the internet, but like we need some sort of process governance around that open source. So the supply chain how of this open source is very important for an organization. So let's look at the first case study, Log4j. It's one of the Java-based open source library, and it's a famous library that's been used by most of the Java developer communities. So Log4j was a wake-up call. For example, in this case, a remote code execution flaw in library affected 93% of enterprises. But here is the kicker: like GitHub had discussions about J&A risks earlier. If you look at the open source community logs, they were discussing about um, the J&A risk associated with it. And OSINT can open source tools could identify some give some indicators about it. So if you look at the attack summary, like yeah, Log4j primarily used for logging, information like whether whether you're logging at info level or debug level. It is used by organizations in enterprise applications a lot to log different levels of information to the logs so that the users can analyze the logs and then take decisions accordingly, right? So and like in that Log4j, there is a it can take the patterns. So in this case, they're consuming a kind of runtime expression that evaluates the JNDI, and with that JNDI, the attacker could inject any JNDI reference and give the expression commands, so that ultimately it leads to remote command executions. So the the author, the who has written about the JNDA, has not performed any validation, input validation. Ultimately, that is the root cause of it, and the other didn't consider the side effects of it. The other, kind of, and it's not intentionally introduced, but it's kind of unknown side effect of that. So the early signs could be like, if someone is monitoring the repository activities, like once the before that it's officially disclosed publicly, there is a sudden surge in forks and commits in the GitHub. So many companies didn't even know whether they are using Log4j or not. So if they don't know whether the company has Log4j, how would they fix it, right? So that's how, you know there is a concept called SBOM, which we'll go in detail later. But many companies don't even know what software component they're using it. So it's like a bill of materials, and SBOM can give the organization what kind of open source components that they are using in any application. So SBOM identify all the instances of Log4j in dependencies, and OSINT can be used to flag suspicious behavior and exploits early in the before even the organizations get compromised. So if you look at the case study of the Maven dependency, so Log4j is Java based, and there is a public repository called for Java world is called Maven. So if you look at the Log4j, applications will be using some dependency. It could be Log4j can be used as a direct dependency, or can be used as in trans dependency. If you take an example of an application, in this case like Spring Boot with version 2.7, the Log4j is not directly involved. Like it's used in another library called Logback, and like if there's someone looks for Log4j in their library, they won't see it directly unless like they go in deep dive into the tree structure and then find if the Log4j used or not. So that's one of the hidden risk. And if it is directly used, they could know like, okay, we are by doing a simple search. um, on the right hand side, you could see, it's kind of a dependency tree. There is a website that gives some sort of dependency, but it's not giving full depth of dependency tree. Like one library is dependent on another library, so then the cycle will continue until like it has all the dependencies, identifies all the dependencies. So the figure that indicates the main dependencies and some of the indirect dependencies, but to kind of demonstrate all the dependencies, it would be a huge decision dependency tree. So if it is direct dependency, it's somewhat easy to kind of find out like how to fix that issue. And if it is trans to, it's like going to be a little difficult to identify whether we have open source Log4j library or not. So then how we can fix this issue is like, first organization is to have SBOM. With the SBOM, they can identify um, whether Log4j is there or not. And with the OSINT, like we could identify these issues early in the life cycle. So what are the early signs? So this is where the OSINT tools are useful. And for example, like the in GitHub issues and discussions, like typically the GitHub has an API. The OSINT tools can consume these APIs to identify whether there are any malicious discussions about the particular library or not. So one of the discussion is, the the researchers raised concerns about JNDI in 2016 itself, even though the attack happened after a couple of years. And these signals were public, but nobody has monitored it, right? So we could, OSINT tools can take consume the GitHub API and kind of monitor that. And surgeon repo activity, as we discussed, like, if a library is being in a specific time window, if you have seen so many forks and starts and like commits, then there is something happening in that library. So that could be either good thing or bad thing. Someone may be fixing the issue, or someone may be kind of have exploiting the issue. So so OSINT can take that as a behavior, the repo activity as a behavior, and also the community as the community websites like Reddit, Hacker News, and Ticker, Dark Reading can also use that as a behavior. So so all this information can be used to kind of check whether the our library is kind of having any kind of special attention or not. So the this has resulted a lot of gaps in the companies. The companies have struggled to identify whether they have log4j or not. So many companies don't have the SBOM, software bill of materials, so they don't know where it is, the log4j is there or not. They struggle to fix the issue, and it's a critical CVE that is reported. And any internet facing public URL could be leveraging this for like penetrating into the organization. So Log4j is a very famous library, and it's there for so many years. So there is a that resulted in panic patching and like incident response and 24/7 workarounds to fix that issue, right? So, but if someone is using OSINT monitoring, they could fix these issues, right? So so organizations don't have visibility into GitHub repos, no inventory of third-party components, lack of insight into nested dependencies. They only look at the direct dependencies most of the times. So security is not embedded into dev teams, so the developers don't even know like whether this issue exists or not, right? So so there are a couple of challenges in different areas, and I have mentioned some of the opportunities and recommendations to do that. So we don't go into any specific tool, but there are tools that are available out there, commercial and open source tool to generate the SBOMs, and continuously monitoring the libraries that are used by the organization. And one of the important aspect is like empowering our developers and conducting regular trainings of open source supply chain risks is important, so that like developers are the entry point who brings the open source libraries into the organization, can be trained to protect the organization. So the other case study is XJ utilities. So in this case it's not vulnerability, it's a backdoor. That means it's a different variant where the developer, one of the maintainer has introduced that a backdoor within that. So it happened in 24, and again nearly compromised the SSH, which is used by all the users, open source publicly or like in enterprise as well. Like SSH is quite common. So the attacker gained the trust of the the other, and then like he started introducing malicious code. So if you look at the timeline, 21 the attacker has joined, started pushing some commits and gained the trust, and started pushing some malicious commits. So and then in 24 the backdoor was discovered. And the way the backdoor was discovered is also quite interesting. It discovered during a performance testing. It's not even like identified by the security professionals. The reason is it's kind of the source code is mixed up with a binary. The binary typically is not get scanned by most of the tools. So it's kind of near miss. And if someone has exploited this, it would have been as bad as like log4j. So how it avoided detection? Like the other has introduced binary blob. It's kind of obfuscation techniques that someone can use it. So inside a thread or outside a threads, they typically use these kind of blobs to bypass all the tools such as SAST tools and SCA tools like source code analysis or like open source library analysis tool. And the malicious user took almost 2 years to commit this attack, and you know attacker pressured maintainers to pursue to merge rush requests as well. Like the attacker. So this fix is important. He kind of obfuscated with some other actual legitimate issue, and then he kind of rushed in the maintainers to push the code so that like the pattern is they didn't even notice. But like some of the OSINT tools can use this, right? So first they can use it like whether that your maintainer is having any reputation in the open source community, and whether he, we cannot check the identity of the users anyways, but like they can check the fingerprint, the behavior of that user, whether he has contributed anything, whether the user has contributed anything into the open source. And the code warnings, like if the maintainer is scanning the repository, then like they would have caught like, hey, why there is a binary file associated in the library which was not there. So does the fix have does the quality issue, the functional issue would have introduced any blob, which is kind of very rare, and they could have noticed it. So this is one of the code scanning gaps as well. And the behavior clues, with the advent of AI and ML, we could feed all this data into a kind of model, like where it can understand the behavior clues as well. Aggressive pushes and forcing the maintainers to rush the code as soon as possible, and strange patterns in terms of the timestamps or some of the clues that we could use it. So in a way, the SBOMs and the OSINT, combining these two, can formulate a defensive strategy for open source community and for enterprises as well. So they need to baseline what is good and what is bad versions of XJ, and then look at the repo health, and look at the what kind of files that they are committing, right? So and then threat intel, like cross check the maintainer identity through some publicly available fingerprints. So the next case study is about SolarWinds. This is compromised through a, a widely used, and by introducing a malicious DLL. So about 80,000 plus organizations have used it, and the exact number is not disclosed, but it has so many millions of dollars impact to kind of fix this issue as well. Um, so OSINT missed opportunities in the sense that you know I it's sometimes, like it is combination of private and public open software, but like if again it goes back to similar to XJ Utils, where they have DLL, and the DLL is in a folder, like, and typically the test folder is ignored by the static analysis tools. So ideally, the test folder should not even go to the production. If at all, if in test, it's meant for the development purposes. It should not cross even the higher environments. So, but most of the software, they exclude that from the scanning tools. Um, you know, th- the threat intel could have been, if organizations consume the threat intel, like they could have been much prepared for that. Like, so again, the OSINT and SBOM could have helped along with the threat intel in this case. Let's look at the other case study. So in this case, it's the maintainer itself is malicious maintainer. So there is a open source library called PyTolier, and it's a combination of two different open source libraries. Some they may be using, like similar package names to kind of trick the developers to use it. So in this case, the other has identified. They use two techniques. One is a stealth technique, where the other has hidden the malicious code with a lot of white spaces. Like if someone open in the editor, typically the developers they don't use word wrap in a code editor. Like so in this case, if you look at this one on line number 3, you could only see some characters of it. But if the developer scrolls it to the rightmost, like after 100 spaces or so, the developer could see the malicious code. But it's very difficult to kind of they use the social engineering technique as well. In this case, the maintainer created a stack, responded to a Stack Overflow request, and then he suggested someone to use this package, and then they're using the pip install and the package name, uh, which can, once the package is inside the code, we could assume that RC is possible in that organization. So So in this case, the maintainer has used both stealth techniques and social engineering techniques. Most of the times, the developers like us like typically go look for some errors when in internet, like, and then like they try to copy paste the same code to fix the issue. So the lesson learned is like, the developer should not download whatever the software that they want to fix, want to download it or fix the issue. So the next case study is very interesting. It's a dependency confusion. So the Alex has documented pretty elaborately in the blog. Um, so this is like led to like Tesla and Microsoft to compromise their internal builds. So let's say if there is a package called internal utils, right? So like in this case, um, the internal utils. So somehow the hacker could know guess what kind of internal packages the organization is using it, and he can the other can replicate it into multiple repositories, whether it's maven repository or python. The other could replicate the same package name into different official repositories with the malicious code. So the trick here is like whenever someone tries to the developer wants to download a library, even though the developer intentionally want to download from the internal repository, but the request goes to external repository. The way the other can trick it in two ways, right? So one, the other can say, always have the highest version. When the package is being installed, the tools will automatically install the highest package, highest version of the package if the others don't, if the developers don't specify the exact version name. So the version, if the version pinning is not there, then it could get it from the public repository, and there could be also like misconfiguration as well. So the attack vector in this case is attacker publishes a malicious package um, to the public repositories, and the build systems will automatically pull that library from the public systems. So it's pretty easy job for the attacker. All that they need to do is identifying the correct package name and adding it to the public repositories. So the Teslas was compromised, Microsoft was compromised on with this one, and I think even Apple was compromised in the he mentioned about Apple as well in the in the blog. So so most of the pipelines are like this, like they have a public repository, and then they have a private repository in the pipeline. If there is a misconfiguration in the pipeline, or the way the developer is misconfiguration there in the even in the developer desktop, it could fetch it from the from the public repository, and then that directly leads to RCE. This is one of the easiest way we can, attackers could use it in the organization. So what is that registry misconfiguration, right? So why do the root cause is the registry misconfiguration, and companies um, relied on scope packages, but they don't enforce any controls like what can be fetched from internet and what cannot be fetched from internet. So there should be a policy around that, and the company should, the pipeline should have the controls. So if you look at this is the npm registry configuration where the registry is directly pointing to the public, and the second line indicates the registry is pointing to the in a internal private registry. So how OSINT can flag this before, like typoscript detections? Like typoscripting is another technique where developers, the hackers, mimic same package name as similar to DNS, right? So we could use if there is a google.com website, the hacker could use google .co dot something, right? com.hp or something like that. So similar to the DNS typoscripting, the typoscripting attacks could happen with um, open source libraries as well, and it's quite frequent that happens, right? So there are libraries like requests in python where the sorry, the developer could mistyping missing some letter that will lead to typoscripting um, uh, compromise as well. So in this case, there is a the attacker has used core fake, and like with azure, um, and the all the attacker just need to do is upload the library and watch for like anybody is using that library and then getting the shell access to them. So there are tools that can detect, could have that flags that malicious packages, and most of the times the malicious packages will not have any dependencies that will lead. I mean, that's also another like suspicious behavior. So the defense strategies could be like, ensuring the package um, should be associated with the repository URL as well, or like, it has to have always the version, and it should point to where it has to fetch from, whether it should be public repository or private repository. That has to be defined in the configuration. And when they generate the SBOM should indicate what repo URL that the library is downloaded from. So this is one of the blind spot in the SBOMs as well. So OSINT tools like Socket and Packet Guardian kind of provide alerts on this one, and we can also do CI/CD hardening. Whenever, so based on the SBOM, it can check, the CI/CD can check whether they pulled it from the public or private, and then the policy can actually, they can have open source policy and block the uh, the usage there itself in the pipeline. So here is a command which indicates how to install from the npm registry using private configuration. Let's look at other type of attacks. So there is something called protestware. So protestware is the term evolved because of the geopolitical situations. I mean, it was there before, like the initial observations are observed like during the college protest and all that, but it has gathered much attention due to geopolitical situations of Russia-Ukraine war. We have seen different types of protest waves. So one of the technique that they use is the typo squatting, which is the easiest one that any attacker can use it, and they can inject malicious code, or they can just simply say, like, support Russia, support Ukraine, whatever it is, and or they could delete the files and all that. So a couple of examples are like event source polyfill, peace no, peace not war. Those are like famous random protest waves that we have seen. So we can categorize the protestware into multiple categories. Repo banner, they they just which repo banner is, it doesn't cause much harm. They just document it in the README document or something, to say they include the protest message. Or they could also display in the CLI logs whenever the library is getting built. They can also show it to the developers, support Russia, support Ukraine, whatever, when during the installation. That also doesn't cause much harm if it is only displaying in the logs. But writing the files and writing the files to different the protestware messages to different files, it's definitely an alarming. Or if you're displaying that protestware messages to the in the public websites, that's also going to be reputation damage for the companies as well. And destructive protest is one of the worst case. It's like similar to RCE with critical score, where it overwrites the files. um, it overwrites the files of the system on the disk, and then, like, it could act as itself is a ransomware. So I included some of the references if someone wants to deep dive onto that. um, So here is the example. Node IPC overwrote files. We look at the case study, the consequence of data loss and then system failures. And colors.js is they introduced infinite loop. So it doesn't cause much harm, but like if colors.js and faker.js are popularly used, but it kind of loads the page, but it hangs onto the customers, right? So sometimes the browser goes into not responding mode. Um, the event stream, they it added malicious code to steal credentials, so it kind of violates GDPR and some end user credential theft as well. In the UA parser, like they, it's compromising of maintenance account and injecting the malware. So this is a timeline graph that we have seen in 2016. Like, the maintainer had some messages, and then the maintainer removed that library, and it the level 9 package kind of created some issue, as most of the dependencies are using about the left pad one. And if you have seen that, like, we have seen a lot of cases from January 2020, late 21 to like 24. And most of them are like Python and Node.js related one. And when it comes to emerging, like with the evolvement of AI, we have seen malicious packages being generated with a type of squatting, a dependency with dependency confusion techniques. AI is kind of generating a lot of packages and kind of putting into the repositories. So, you know, lot of like the thousands of packages are added into repositories, and it's very difficult for someone to maintain that kind of repository if AI started adding um, the open source libraries. So this is one of the protestware that we have seen, event source polyfill. So it's kind of displaying the geopolitical messages, and it didn't cause much harm, but it just opens the window with supporting either one of the country. And proactive measures that we could take is like analyzing the source code. That's best we can do. And whenever we get a package, we need to kind of do that kind of analysis, or we need to rely on the threat intels from the public source, which sometimes it could be too late as well. And like one way we could prevent is like don't download the latest library always. That's so let's move on to the next one, the node IPC. This is also one of the protestware messages, where um, it completely introduced because of the geopolitical situation, right? So the open source is impacted because of the Russia and Ukraine war. So Node IPC is a popular library. It has about 1 million downloads. So the maintainer added a file wiping code to protest Ukraine war, like based on certain time zones and IPs. It will delete the files on the system. Whenever the build happens, it deletes the files. So there is no way to go back on this one. So this can be classified as a ransomware, but it's better to classify it as a protestware because it's specifically hard coded to the specific time zones and IPs. So as you can see, some of the included sample code is if it belongs to Russian IP, delete the files and with some piece to push not part messages. So this is again nested dependency example. Like how OSINT can help is like flagging sudden version changes and commit history and maintainers reputation and public stance on social media. In this case, the maintainer itself, like in case of war situations, life and death situations, the maintainer would obviously do support his country and include such messages as well, right? So it's a kind of warlike situations. So let's talk about defenses. We talked about different attack scenarios, and so the governments are have to take initiatives across different countries. So in this case, US has has introduced executive order that the suppliers of the software needs to include software bill of materials, and they without that, like the third the vendors agreement will be nullified, and and it forces the organizations to comply with that. So this the federal this the um, because of that, a lot of businesses have got impacted, but to kind of meet this standard. So what is software bill of materials? It's a detailed inventory of what components that software is made of. So so whether it's open source component or like is a third party private source component, we need to know what kind of software that the soft application has, and we need to know the dependencies of each software. So it's kind of a complex a dependency tree that someone has to support it, right? So then only the organization would know whether they are using that library or not. So this is especially challenging when we don't have the source code and we are relying on the third party. So before accepting any third party software, then we need to request for the software bill of materials. So this gives us better risk management and identify. We can once the library is there, versions are there, we know what kind of vulnerabilities it has. We can look it up. We can leverage our threat intel tools. If you don't know that what library, we cannot use any of the tools. We cannot do any risk management as well. So this is very crucial piece to do the open source risk management. So facilitates compliance and meet the regulatory requirements as well. Um, so once we know the library, when once we have the threat intel, we can know how fast we can respond to those incidents. So the SOC and SOAR platforms can leverage these SBOMs to check for vulnerabilities on a continuous basis. The role of SBOMs, like organization should adopt the SBOMs to at least definitely to meet the regulatory compliance. If not, they will be use fine if they don't meet. And this also helps the organizations as well to mitigate the risks. So, for example, like just to illustrate purpose, I compared automobile SBOMs. Our bill of materials is quite common in automobile industry, where the car, if you take about car manufacturer, the manufacturer relies on a lot of um, suppliers to kind of provide all different parts. Like fuel system could be having different parts, and propulsion system, or electrical system, or like the digital systems, brake systems. Like they all have different components, and then it's a lot of it's a complex supply chain when it comes to automobile. But like we also have similar complex supply chain when it comes to software. We don't realize that, right? Since it is like software, we have taken it for granted. But this supply chain issue is there um, for ages. But like we just organization started adopting, reacting to this because of the recent incidents. So the SBOM is software bill of materials, which will tell us like what kind of licenses, what kind of CVEs associated with the libraries, and what are the supplier names, what are the versions. So it can other names. It gives a lot of information. Depends on like how granular they are providing the details. So these are one of the example of SBOM in a YAML format. As you can see, this is my project, and then I have dependency called log4j here, and then it shows the version name and the version number, description, and the what kind of license. So it covers different aspects, the legal aspects, legal compliance aspects as well. And once we have this information, the organization can better prepare for as similar to regular software patch management. So it provides detailed map, and it kind of enables organizations to um, better prepare for it. All right, let's go into the one of the prevention method. So this is one of the model that in my opinion organization should adopt, and most of the organizations are adopting it. So let's take a example here. So in this case, the developer, who is the main source. So we kind of onboard the development. The organizations do the background check, and then they know the identity of the developer, and then they kind of allow the developer to commit the code. But the developer bring open source without knowing any of the identity of that open source contributors. So um, I think some organizations are still doing it, but like most organizations are relying on CI/CD pipelines, and they have their own repositories. But if someone is directly fetching the library, that should not be allowed anymore, because that creates uh, a lot of risk to the organization, and there is no centralized management of the libraries. So this should be avoided immediately. No, the developer should not be using the library from internet directly. The developer should be fetching it from the internal repository. So the proposed model is the developer um, will have a source code, and they should not be adding the libraries into the source code repositories. Um, but they have to declare what libraries that they want to use it. So most of the programming languages, they have their own source code package managers. So in this case, Python has pip and Maven, but they have their own configuration files to kind of declare what libraries that the developer wants. So developer would request, and the request should be going to the internal repository first. In the internal repository or the pipeline, they could check, ensure the code doesn't have direct downloads. uh, um, if someone is downloading directly from that, then the build should be failed, and it should not be even allowed to the higher environments. And the build server should fetch the libraries. The build server should fetch the libraries from these internal packages. And then like the pipeline should have, okay, whether this library is allowed or not. So they should have a approve or disapprove, or further review kind of statuses within the pipeline itself. So the internal organization should have its own repositories, and they should continuously scan for those internal repositories as well. So they should review the licenses and whether it's fitting the license model is fitting into the organization policies or not, and what is the popularity and ranking of the library. Where do we want to use that library? Who is the maintainer of the library? So that organization can impose these kind of restrictions before fetching the library. And if the company is in a sanctioned zone, are not allowed to do kind of trade in specific countries, or due to geopolitical or war-like situations, the organization can take a policy that we should not be accepting any of the open source libraries originating from this kind of country, from this particular country, and like that. So ideally, it's a complex scoring mechanism. On this one, like I have developed a open source policy guard as a sample, I have included later in the slides. Um, so ultimately, the organization should do all these checks before they add the library into the internal libraries. And so open source policy is the one that defines what is allowed and what is not allowed, what kind of ratings we should assign to the library. There are some open source tools that organizations can leverage, but like organization should have its own specific scorecard as well, on top of the public scoring mechanisms. So applications and open source inventory will be maintained here, and internal package should be maintained in separate repository as well. And what are the libraries that are originated from external, they should go through the continuous scanning and monitoring with the threat intel from various websites. So as we discussed, the prevention measures is like conducting regular security audits, and having the organization should have the control of the on the dependencies. They should have the dependency management, and the organization should also contribute to the open source to make those, whatever the open source libraries that they are kind of consuming, they should have active community engagement. That way they can kind of get more control of visibility of the open source libraries, and giving back to the community as well. And organization should also have automated security tools to kind of identify the known CVEs. So here I included some of the tools. I categorize the tools into different concepts. So for example, like the first category is foundational and ecosystem-wide tools. This is the basic that any organization should adopt. There is no compromise on this one. And I mean, some not they don't need to use all the tools, but there's some of these tools indicators that they need to use. So for example, OSS.dev is one of the open initiative, and Google is primary participant of this. It's all part of OpenSSF. It's a working group. There are a lot of working groups on that, and a lot of open source projects are actively happening to combat these supply chain attacks. Right. So OSS.dev uses like a lot of open source intelligence to check whether that library is malicious or not. So we have seen different types of attacks. So whether it's a malicious package, protestware, like it kind of identifies it. It doesn't identify. There is something called open source malicious package repository. This package is developed specifically for identifying the malicious nature of the libraries. It doesn't look at the vulnerabilities at all. So OSS Dove takes the feed from malicious packages and different aspects of the open source to kind of provide intelligence to the on a particular library. OSS policy guard is policy as a code. This is what I'm talking about, like where you can have a policy as a code in the pipeline to combat this supply chain issues. So this open source OSS policy guard relies on a lot of tools like OpenSSF and others to kind of come up with a scoring, and it will provide either approve or disapprove during the pipeline if developer sends a library name as part of it. So this is in early stage of development, but this kind of tool demonstrate how one can develop within their organization. The next one is real-time repository monitoring. Again, it's kind of difficult to monitor the behaviors of it, but with the advent of AI and ML, like we can take different feeds from different open source tools and analyze the behavior of it. So, what are the audit the GitHub repo? of the nested dependencies, commit history, and then the health of it, how frequently they are resolving the issues. That also matters, right? And the suspicious changes, like is that account has been taken over, or is it a new maintenance? We, if it is so, the risk will levels will be little high over there. And organizations should also add, even though they have commercial tools, they also need to look at the advisories. Like GitHub has its own advisories, so they need to kind of rely on GitHub advisory and the oss.dev advisories to get the information. Most of the commercial tools, they are lag behind updating their knowledge base. The other one is threat intel. This is where a lot of OSINT tools can help us to combat supply chain attacks. OSV scanner, NIST feeds, one cost are some of the examples. One cost is not actively maintained anymore. SNCC has its own knowledge base to provide the threat intel. And the community watchdogs, signals. So this is interesting. Before the exploit happens or the malicious code is revealed to public, this way a lot of forums the discussions would happen. Like, we have to look at the GitHub trending, spike in downloading it, and looking at the exploit POCs in GitHub, and alerts, subscribing to RSS alerts in different different social platforms, open source platforms, and looking at exploit DB and Reddit, Hacker News. And so these are like, watch for specific open source libraries, which is difficult if the organization has a lot of open source libraries, but it's worth implementing it with the, with the advent of AI and ML. This job will be pretty easier. The geofencing is another new concept. So whether it's a trade war or physical war, geofencing, open source used it as a weapon. So the geofencing has to be implemented by organizations, if they are like if they are affected by those war-like situations. And the behavior logic as well. Once the library is there, they can load into a dynamic analysis tools to kind of observe the runtime behavior of it as well. And developer sentiment, like once we know who are the developers, and look at their handles in GitHub and look at their post, and then get a sentimental analysis report of the open source package. This also wasn't helps a lot here. These are like not implemented anywhere, but like this is where the supply chain can leverage OSINT tools to kind of adopt it. So best practices, just to summarize what we discussed, open source policy should be there, and there should be a scoring mechanism. And then they are in the pipeline, automated in the pipeline, they need to define automated approvals of open source based on the risk, and automated dependency monitoring. Make sure that the libraries are approved, and if there is any compromised dependency, we should block that library as soon as possible. And leveraging OSINT tools into the pipeline is something that organizations are lacking. They should do it more often as a part of the strategy. SBOMs, leveraging SBOMs is a proactive threat management, but like, SBOMs has its own blind spot as well. Like, they need to use leverage VEX and other scoring mechanisms in combination of SBOMs. So SBOM and OSINT combination will make that libraries more secure, and organizations are better prepared in terms of identifying any supply chain issues. So screening of open source, protestware, sudden behavior changes, this is continuous monitoring that needs to be done, and act immediately. Most of the times, once we know it's a protestware or malicious, organizations should implement a SOAR platform to automatically block that library, and or like to kind of retract to the previous version of the library. With that, I will conclude with few takeaway points. Planning and monitoring is key, and collaboration is important. Supply open source has a lot of space to collaborate, and leveraging OSINT and SBOM is a key to for business to survive if they're relying on open source software. And with emerging technologies like AML, then they should organizations should protect their customers' operations and reputation, and avoid any compliance issues by following the integrity of the supply chain. With that, I conclude my presentation and open for any questions.